a brand new way to solve quadratics. I'm super excited to share this with you. This should replace the quadratic formula and also the grouping method used to solve for x if you have a quadratic. This is going to be something that hopefully you use anytime that you don't have a nice easy factoring question when a is 1. Okay, so without any further ado, let's start the lesson. So before we get into the new lesson itself, let's just make sure that we can do the prerequisite skills that you need in order to perform the solving. Okay, so first thing we want to make sure that you can do is multiply two binomials. Okay, so we know that if you remember the FOIL method, first times first, the two outers multiplied, the two inners multiplied, and then the last times the last. Okay, if you do that multiplication, then you end up with x squared, and you end up with x times minus 5 is minus 5x. Then minus 2 times x is minus 2x. Minus 2 times minus 5 is positive 10. Okay, we're going to then look to simplify by combining our two like terms. So our final answer is going to be x squared minus 7x plus 10. No like terms to combine. Okay, let's do that one more time. And let's multiply 10 minus u times 10 plus u. Now this is going to be a nice one because we have two conjugates. Okay, conjugates have the same a term and the same b term, but they have a different sign in between them. And what happens that's really nice with the conjugates is that when you FOIL them, the o and the I, the outer and the inner terms, they cancel. Okay, so when we go first times first, we're going to go 10 times 10 is 100. The outer is going to be 10 times u, so positive 10u. We're going to do the inner, you got minus 10u. As I said, they're going to cancel beautifully, so plus 10u minus 10u. That's a u, by the way. And then minus u times minus u is minus u squared. So if you are looking to combine like terms, as I said, you cancel those two middle terms out, so you get 100 minus u squared. Now, if you know the difference of two perfect squares rule, you know that 100 and u squared are both perfect squares. You know that that subtraction in between means it's a difference of two perfect squares. So you can take the square root of 100 and then the square root of u squared, and you put the plus minus in between. So if you were factoring this answer, you would go right back to your question. Okay, so that's first thing you need to be able to do. Second thing you need to be able to do is to solve when you have two factors multiplied together and set them equal to 0. Pretty simple stuff here. If I have, because of the zero product property, if I have x minus 2 as one factor times x minus 5 as another factor equal to 0, then my solution could be that x minus 2 is 0. So if I have x minus 2 equal to 0, then that means when x is 2, then I am going to get a 0. So x is 2 is a solution to that equation. Likewise, the second factor, if the second factor yields 0, then you add 5 to both sides, you get that x is 5. So 2 and 5 are my two solutions to this original question here, right? So the pattern is going to end up being that if you have x minus blank as a factor, then that blank is going to be a solution. So if you have x minus 10, 10 is a solution. Okay, factor of x minus 20, then 20 is a solution. Okay, so let's look at a couple more here. Let's split these two factors up. So x minus 13, the first factor, if that equals 0, then 13 is a factor. Excuse me, 13 is a 0, okay, or a solution. And if x minus 22 sevenths, if that factor is equal to 0, then we add 22 sevenths. Then one of the solutions is 22 sevenths. Okay, so if you generalize it, x minus a times x minus b, okay, split those two factors and say that either one of them could give you 0 for this to be a true equation. So that means if you add a to both sides, x could equal a. If you add b to both sides, x could equal b. Right? Pretty simple stuff. X minus blank is a factor, blank becomes a solution, and that's how you solve them. Okay? Those are your prerequisite skills. Okay? Let us continue on to start making some connections between what you've done and what we're about to do. So, some connections. If we have this factoring question, okay, solve this nice, easy, factorable quadratic for X, right? And if you remember what we've done in the past, right, you would say, I want to find a product. Okay? The product is going to be the C term, okay, which is positive 12. Okay? And I need the sum, and the sum is going to be the B term. Sum is going to be negative 8. Okay? So I need two numbers that their product is positive 12. So it could be 1 and 12. It could be 2 and 6. It could be 3 and 4. But their sum has to be negative 8 because that's your B term. Okay, so if we use negative 2 and negative 6, negative 2 times negative 6 is product of 12. Awesome. Negative 2 times negative 6 is good, but what if we add them? It's negative 8. Yay, that's awesome. Okay, so that means you take that minus 2 and you put it right there. You take that minus 6 and you put it right there. That's factoring. Okay, that's factoring. Then once you get x minus 2 times x minus 6 equals 0, then you can go right back to this prerequisite that we talked about. This is the type of thing that we're looking to be able to solve, right? So you would have x equals 2 for one solution, x equals 6 for another solution. Sweet. Okay. Hopefully you know how to do that. If you know how to do that, that to me complements our solutions only method that we're going to be doing very, very well. All right. So let's look to make some connections between these answers, these solutions that we got, and the graph, and just some other stuff that's going to bring us to our solutions only method, right? So where are the solutions on the graph? So where's the x being 2 and x being 6 on the graph? So I took the liberty of graphing x squared minus 8x plus 12, which was our question here. If you graph it, you get this lovely red parabola, right? So this right here is the actual graph of x squared minus 8x plus 12, right? So where is x equal to 2 and x equal to 6? The answer is the x-intercepts. They're on the x-axis, right? So we're going to write that. So the x-intercepts will give us our two solutions, okay, visually. If we have two real answers, it's going to be where the x-axis is intersected by your graph. Okay, so now let's make some investigative questions here. What is the sum of my solutions? Well, my solutions were 2 and 6. So 2 plus 6 is 8, and it's a positive 8. Easy enough. Well, how does the sum connect to the equation? Are there any 8s in the equation that we had? Well, there's an 8 right there. That happens to be a negative 8, though. So it's the opposite sign of the b term. Okay, so the b is negative 8, but I want to know about positive 8. So that right there tells me that the opposite sign of b, or negative b, is going to be the sum, at least according to this particular equation. Now, what will the average be between the two solutions? Well, how do you take the average of two numbers? Well, you add them together, which we just did, okay? And we just said that when you add them, that's negative b. Okay, you add the two numbers and you divide by 2. Okay, so the negative b divided by 2 is going to be my average. So 2 plus 6 over 2 is 4. In this particular question, it's 4. Question 5, where is that 4 on the graph? So where is x4? Well, check it out. X is 4 on this line right here. Okay, X is 4 on that line. That line is called the axis of symmetry because it literally cuts our parabola into 2 mirrored reflected halves, right? So where is it? It's on the axis of symmetry. Okay, so X is 4 right there. Okay, so that's my average, right? Where X is 4. Right? So now it says express each of the solutions in terms of the average. So my solutions were 2 and 6. Okay, so what was the average again? The average was 4. So 2 is 4 minus 2. 6 is 4 plus 2. And go back and look at your graph. There's my 4. If I add 2, there's my 6. If I subtract 2 from my 4, there's my 2. So you can literally see it right on your graph. You can see that your solutions are both 2 units away from the average of the solutions. Okay? So because that's going to be, since we're looking at the average, the middle is going to be the same distance away from each solution. We can say I start with the average and I add a number. I start with the average and I subtract the number. That's how I get my 2 solutions. All right. We're going to call that number U in a little while. We're going to use the letter U as a variable. Okay. Okay. Continue on here. What is the product of our 2 solutions? Okay, well, 2 times 6, those are our 2 solutions, is 12. And it's a positive 12. Okay, that's easy enough. And then finally, we ask you the question, where do you see that product of positive 12 in the equation? Well, let's go back to the equation. All right, I see a 12 right there, and it is positive. So the C term is the product. Okay, just like in factoring, the C term is the product. So to answer my question here, the C term is where I find the product. All right. So we just analyzed solutions of one factored and solved quadratic. Let's do it one more time just to reinforce, and then we'll actually do steps and we'll start solving some quadratics using the solutions only method, which I'm really excited about here. Okay, so let's look. We're going to solve this quadratic, okay? So we are going to factor, okay? We're going to use the product sum method, right? So the product has to be positive 8, which is the C term. That's basic factoring, right? A times C, 1 times 8. The sum must be the B term. That's going to be negative 6. So if I take negative 1 times negative 8, I get positive 8. But if I add those 2 terms together, I get negative 9. I don't get the negative 6 that I wanted. But if I take negative 2 and negative 4, they add up to negative 6 and they multiply to positive 8. So I'm going to take the minus 2 and the minus 4, and I'm going to set them up here as factors. Okay, now we're going to go back to that prerequisite skill that you need to be able to do, and we're going to split and solve. So x minus 2 could equal 0. Add 2 to both sides, x is 2. The x minus 4 factor could equal 0. Add 4, so my solution there is x is 4. Awesome. So I've got x is 2 and x is 4. let's examine our solutions again. What is the sum of our two solutions? Well, 2 plus 4 is 6. Check it out. My b term was -6. So once again, my sum is the opposite of, or negative, b. Okay, so you're going to change the sign of b. That's the sum. What's the average of my two solutions, 2 and 4? Well, 2 plus 4 divided by 2 is 3. So what is that? That's the sum, negative b, divided by 2. Okay, so it's the same pattern as we had in the previous question that we looked at. Okay, so now let's look at what is the product of my two solutions. Well, 2 times 4 is 8. That's a positive 8. Where do we see positive 8 in your quadratic? Once again, it's the C term. Positive 8 is the C term. Okay, so in terms of the average, so in terms of the in terms of the average 3, okay, we're going to use the 2 and the 4. So 2 and 4 are my two solutions. Okay, so 2 is the average minus 1. 4 is the average plus 1. Sweet. Well, that should make sense. That means that you know, the axis of symmetry is 3, and then if you go 1 unit to the right, you get the 4, and 1 unit to the left, you get the 2. Okay, with that knowledge, here are your steps to solving any quadratic. Okay, these were nice factorable ones. This will allow you to solve non-factorable ones, quadratics that have solutions that are imaginary, anything you can solve now. All right, 2 things. First off, you must have equals 0. If it doesn't equal 0, make it equal 0. Like if it said equals 5, then you got to subtract 5 from both sides of the equation and make it equal 0. So make sure that that is there. Okay, make sure there's an equal 0. Okay? Second thing is a must be 1. Right? So if a does not equal 1, then make it equal 1. Yeah, then divide all terms on both sides, okay, all terms here by a. Okay, if it's 5x squared, divide everything by 5. All right, once you have equals 0, and once you have a being 1, then you can do the following things. You have to find the average of the solutions. Okay, the average is going to be negative b over 2 every time. The product of the solutions is going to be c every time. Then you're going to set up the following equation. Now, since the averages are negative b over 2, then we can say whatever negative b over 2 is, okay, because the equation is going to give that to you. It's going to give you the b. Negative b over 2, that number plus something, we're going to call it u, and minus something. Okay, that is how we're going to say we have our solution. This is my first solution, and this is going to be my second solution. And when we multiply our two solutions together, we get the product of our solutions. And our product of our solutions is the C term. Once you have that little algebraic equation, you're going to solve for u. And then once you have u, you simply substitute that in, say my average plus that u and the average minus that u are our two solutions. Okay, I'm excited to do one of these with you. Okay, I'm excited to show you one. All right, we're going to use some nice numbers here first for our first couple of questions. So again, if you do these in a factoring method, that's fine. I would do that as well because these are pretty simple. I mean, you can look at you know, product is 9 and the sum is -10, and you can do the factors from that pretty quickly. But once you get quick at this, this is not going to be very long at all. So I would almost recommend, you know, thinking about doing this method all the time. So let's check it out. So the first thing I'm going to ask is, what is the average of my two solutions? Well, that would be -b/2. B is 10. So negative b would be +10/2 is 5. Okay, so I've got my average. So that means my solutions are 5 plus some number, because the average 5 is going right down to the middle. That's my axis of symmetry. It's cutting my graph in half. So 5 plus some number is one of my two solutions, and then 5 minus that same number is going to give me my other solution. So all I need to do is find out what u is, and then it's 5 plus it, and then 5 minus it. So we need an equation to solve for u. My equation needs a product. The product of my two solutions is going to be my c, which is +9. So my equation is as follows. My first solution times my second solution, make that a little prettier, equals my product. Okay, now we just need to solve for u. So let's FOIL this out. When we FOIL it out, we get 25 minus 5u plus 5u minus u squared, and then bring down your equals 9. Right? Since they were conjugates, we got minus 5u and plus 5u. They are going to cancel out beautifully. So that's going to be 25 minus u squared equals 9. All right, now you can do this a couple different ways. I don't care if you subtract 25, divide by -1, and then take your square root. I have no problem with that. I do it this way, so I'm going to show it. I'm going to add u squared to both sides. That will cancel these u squareds out. And so now I want to get rid of this 9, so I'm going to cancel it by subtracting 9. Right? So that's going to give me 16. This side cancels right here. So 16 plus 0 equals 0 plus u squared is u squared. All right, so now we have to solve for u. We're going to square root both sides. And anytime you square root both sides of an equation, you need to remember to plus minus your answer side. All right, so u is equal to plus or minus square root of 16 is 4. Nice. So now we know what u is. Okay. Now, I would say this. U is the distance between the axis and each solution. So distance is always going to be positive. So you don't really need to remember that negative part of it on the plus minus, but I do want you to get in the habit of putting the plus minus there, because in other topics, when you square root both sides, you are going to need that plus minus. All right, so it's a good habit to have. So now we're going to take what we know the solutions are and do a little substitution. So I know that 5 plus u, or 5 plus 4, is my first solution, which is 9. Then 5 minus u is my second solution. 5 minus 4 is 1. Okay? So I know that x equals 1 or 9. Great. Now, if you say, well, what if I did try that -4? Okay, well, I'll take just a quick second and address that. So if I go 5 plus -4, I get the 1. And if I go 5 minus -4, I get the 9. So you're still going to get the same exact answers. You're just, going to use the negative. That's fine. But you're still going to get the same exact solutions to your quadratic. Right? So nice numbers, very factorable. But let's use our solutions only method again right here on this question. So once again, first thing I need to know the average of my solutions. And that's going to be negative b over 2. So positive 18 over 2, which is 9. Okay, I'm not going to write out quite as much this time. So let's buckle in and make go just a little bit quicker. All right, so my solutions are 9 plus u and 9 minus u. If I multiply those two solutions and set them equal to the product has to be c, positive 32. Now I can solve for u. All right, so here we go. I'm going to FOIL it out. So I get 81 minus 9u plus 9u. They cancel. Minus u squared equals 32. Okay, now I'm going to solve it the way I like to. So I'm going to go plus u squared. I'm going to subtract this 32. 81 minus 32 is 49. On the other side, you got u squared. Okay, I'm going to square root both sides of the equation, stick a plus minus when I square root both sides, and I've got u equals plus or minus square root of 49 is 7. So what are my solutions? The solutions are, the first one is 9 plus u, and the second one is 9 minus u. Okay, so 9 plus u, well, we know that u is 7, and 9 minus u is 2. Okay, so the solutions are x equals 2 or 16. Cool. Now those are nice numbers. Those are very factorable. Let's try one that may not be factorable. Yeah, so the only factors of 13 are 1 and 13. I can't get an 8 or a negative 8 out of 1 and 13. So I know this would be one that I'd have to use the quadratic formula or completing the square to solve. I just want to use the same method, right? So what is the average of my two solutions? The average of my two solutions is going to be negative b over 2. So positive 8 over 2 is 4. So I know that my solutions can be written like 4 plus u and 4 minus u. And I know that if I multiply them, I'm going to get my product, which is always the 13. Okay. So let's FOIL this out. 4 plus u times 4 minus u. We get 4 times 4 is 16. The outer and the inner terms plus 4u minus 4u cancel. I get minus u squared equals 13. Okay, I'm going to solve it the way I like to. I'm going to add u squared. I'm going to subtract 13. So I get 3. These cancel nicely. So 3 equals u squared. I'm going to take the square root of both sides. Don't forget my plus minus, just to solidify a good habit. So u is going to be plus or minus root 3. 3 doesn't have any square roots, perfect squares that are factors of it. So it just stays root 3. So what are my solutions? 4 plus u and 4 minus u. So 4 plus root 3, 4 minus root 3. Now you can't combine non-like terms here. So 4 plus root 3 has to remain 2 different terms. 4 minus root 3 has to remain 2 different terms. So x equals those two answers right there. Cool beans. Done. Okay, so as you can see, we're doing a little bit quicker each time. You want to write all the steps, write out all the steps. Okay, just like we did right in here. All right, that's fine. Write them out until you don't want to write them out anymore, until you think you can do it. Okay, now this one is going to be a little different as well. All right, this is going to have a different type of solution. We'll talk about that in a minute. Okay, so what is the average going to be? The average is going to be negative b, so positive 6 over 2, which is 3. So my solutions are going to be 3 plus u and 3 minus u. And if I multiply those two solutions together, I'm going to get the C term, positive 13. Positive 13. I'm not going to write the plus. There you go. Let's go ahead and FOIL. Okay. 9 minus 3u plus 3u cancels. And then we got your minus u squared. So 9 minus u squared equals 13. Awesome. Okay. So I'm going to add my u squared. I'm going to subtract 13. So that gives me just the u squared over there, which is what I want. Cancels. Okay. U squareds here cancel. Give me 9 minus 13, which is negative 4. Ah, that's why this one's different. So when I take the square root of both sides, I've got myself the square root of a negative number. Okay. Hopefully, you have already taken some algebra. Algebra 2, I know that we cover square root of negative numbers, imaginary numbers. So u equals plus or minus. Okay, so square root of negative 4. I'll give you a quick refresher on that. All right, so negative 4 is negative 1 times 4. So I'm going to split the square root of 4 up into the square root of negative 1 times the square root of 4. Square root of negative 1 is I. Square root of 4 is 2. So 2 times I is 2I. Okay, so u is 2I. It's an imaginary number. That's fine. We're still going to substitute it right in for my two solutions. So I know my first solution is 3 plus 2I. And my second solution is 3 minus 2I. Okay, just like when you have a variable, you can't combine like terms by adding or unlike terms by adding or subtracting. So 3 plus 2I remains 3 plus 2I, and 3 minus 2I remains 3 minus 2I. So x equals these two imaginary numbers right here, these two complex numbers. Okay. Now, for those of you that are visual and you say, wait a minute, if we're supposed to have x-intercepts be my solutions, what gives? There's no 3 plus 2I on my number line. Okay, well, I've graphed it for you. Okay, this is x squared minus 6x plus 13 right over here. Right? So notice this is the x-axis down here. And there are no x-intercepts. Okay, there are no x-intercepts. So that means the solutions can't be real. So visually, if you get i's in your answers, your solutions, your x-intercepts are imaginary. Okay, so that means that this parabola never intersects the x-axis. So your solutions are not real. Any of you that watch The Office, it's one of my favorite scenes where Creed says, "You're not real, man." Okay, so we're going to move along. Do a couple more examples here just to give you some more practice. Okay. What is my average? The average of my two solutions is going to be negative b. Okay, this time b is positive. This is a different type of question. Will it work if b is positive? We're going to find out. Okay, so negative b over 2 is negative 12 over 2, which is negative 6. Okay, well, that means that my two solutions are negative 6 plus u and negative 6 minus u. And I know that if I multiply my two solutions, they're going to be equal to my C term. Oh, look at that. We got a negative C term. That's a new one as well. Cool. All right. We just do the algebra, folks. Okay. Nothing changes. The steps stay the same. If I FOIL this, 36 minus, plus 6u minus 6u. Once again, we have conjugates multiplied by each other, canceling out the middle terms. We get 36 minus u squared equals negative 5. Okay, let's continue on. Again, this is just how I like to do this. You don't need to if you don't want to. That's fine. I'm going to add 5, add 5. So I get 41 is equal to u squared. Sweet. Take the square root of both sides, plus or minus to build a good habit. So u is plus or minus. Now 41's prime. It's not a perfect square, so I'm just going to keep root 41 there. So my two answers are -6 plus u, which is root 41, and -6 minus u, which is root 41. Now these are real numbers. There's no I in there. So these actually will be x-intercepts. They'll be real numbers. Irrational, but real. But it's kind of cool just to get a different type of a question in there with a positive b and a negative c. Okay, so let's move over to another funky one here. So this one's funky because now I'm giving you a b that's going to be odd. So the average is negative b over 2. So that's positive 5 over 2. And folks, as much as I like decimals, I like to square fractions even more than decimals because you just square the top and square the bottom. Okay, square numerators, square denominators. So my average is 5/2, which means that my two solutions are, you guessed it, 5/2 plus u and 5/2 minus u. So if I multiply those two solutions, I get the product, which we know is going to be this c term. Awesome. Okay. Let's FOIL it. 5/2 times 5/2 is 25/4. Okay. Minus 5/2 u plus 5/2 u. Again, the conjugates cancel beautifully. And then plus u times minus u is minus u squared. Okay. We're just going to keep on doing it. Same steps, nothing new. Okay. We are going to add u squared. Now I got to cancel this -1. So I'm going to add 1. But I want to add 1 in a form where I have a denominator that's 4, because it's going to be easier for me in the next step. So 1 can be written as 4/4. So I'm going to add 4/4 to both sides of my equation. Okay. Great. So over here, those cancel, leaving me with u squared. Over here, those cancel. 25/4 plus 4/4 is 29/4. Okay, our last step. Again, nothing different. And square root both sides. Put plus minus to remind ourselves there. So we get u. Okay, now take the square root of the numerator, take square root of the denominator. Square root of 29. 29 is prime. So it stays square root of 29. Square root of 4 is 2. I like that. Okay. We go back to our solutions. So I have 5/2 plus root 29 over 2. I have 5/2 minus root 29 over 2. Now, the only thing that you may do to simplify this is to combine those fractions into one fraction. You say, well, 5 and root 29 can't combine into one term. You're right, but we can add halves and just keep the 5 plus root 29 as 5 plus root 29, and therefore we have one fraction. So 5/2 plus root 29 over 2 can be written as 5 plus root 29 all over 2. And then 5 minus root 29 all over 2 can be my second solution. Yep, that's a 9. Let's make it look a little prettier. Root 29 over 2. Nice. Okay, so there's my second solution from there. Okay, so that's what x equals, those two solutions. Okay. And I think that's some good practice, but remember we said, what if a isn't 1? Doggone it, let's do one of those. Make it be 1. I'm dividing every term on both sides of the equation by a. A is 2. Okay, I need it to be just x squared. I don't want 2x squared. So if I do that, I get x squared minus, I'll put the 1 there, even though you can do invisible math and just put it as x. Okay, I'm not going to mess with my fraction. 3 halves is good. 0 halves is 0. I am going to mess with that. Okay, now that I've got the a is 1, proceed, you may. Okay, not a big Star Wars guy, but figured someone might get a kick out of that. Okay, so I have my A, I have my B, I have my C. Now we just do what we do. Okay, so the average of my solutions is going to be negative B, which is positive 1 over 2. Cool. That means I can write my two solutions as 1/2 plus u and 1/2 minus u. And I know if I multiply those two solutions together, I'm going to get the C term, which is negative 3 halves. Okay, so let's do our multiplication. Let's FOIL this out. 1/2 times 1/2 is 1/4. The outer term is minus 1/2 u. The inner term is plus 1/2 u. They cancel nicely. And then for the last term, as usual, it's minus u squared. Okay. Then bring your negative 3 halves down. All right. We do what we do. We do the algebra. I'm going to add my u squared to both sides. I'm going to cancel out that negative 3 halves by adding. But again, I want to have the same fractions denominator as this 1/4. So I want this to be something over 4. Well, 3 halves is 6/4. So I'm going to add 6/4 to both sides just to make it easier on me on the left side. Okay, these cancel, these cancel. Right? So when they cancel, what we have left is u squared on the right. 1/4 plus 6/4 is just 7/4. That's why I like it, because that was easy. Okay, now let's take the square root of both sides. Don't forget plus minus to build your good habit there. Okay, so you got u here. Square root of 7 is the square root of 7. Square root of 4 is 2. Great. So u is root 7 over 2. So we can state that our solutions must be 1/2 plus u and 1/2 minus u. So 1/2 plus root 7 over 2 and 1/2 minus root 7 over 2. Okay? And then just like the previous question, we have two fractions that have the same denominator. So I can combine them to make one fraction. So I'm going to combine that first solution, and I'm going to have 1 plus root 7 over 2 for the first solution in simple form. And then for the second solution, I'm going to have 1 minus root 7 all over 2. Okay, so that's what x equals. Those are my two solutions, right? Very excited to share that with you. Give me some feedback if you wish, but you can now solve any quadratic whatsoever with those steps. Good luck. Ask questions. See ya.